Good morning, student. Today the topic of discussion is explain why low plasma proteins cause edema. Edema is defined as collection of fluid in the interstitial space. Filtration of fluid across capillaries is governed by Starling's hypothesis, which states that Kf into Pc minus Pif minus pi c minus pi if. Here F is the filtration rate and Kf is the permeability coefficient, or we can call it the filtration coefficient. It depends on the permeability of the capillaries and total capillary surface area. Hydrostatic pressure is denoted as Pc. The hydrostatic pressure of the capillary is Pc and hydrostatic pressure of interstitial fluid is equal to Pif. Whereas oncotic pressure of the capillary is pi c and the oncotic pressure of the interstitial fluid is pi if. At the arterial end, the fluid is forced out of the capillaries into the interstitial space by this capillary hydrostatic pressure. And at the venous end, on the other hand, fluid is drawn inwards into the capillary by colloidal osmotic tension. Now, PIF or hydrostatic pressure of the interstitial fluid, it is negligible, and pi IF, that is interstitial fluid oncotic pressure, also it is very low, that is 3 mm of mercury. So if we calculate the filtration pressure at the arterial end, we will see that it is equal to 35 mm of mercury, that is the hydrostatic pressure of capillary, minus 0, that is the hydrostatic pressure of interstitial fluid, minus the oncotic pressure is 25 mm of mercury, minus 3 is the oncotic pressure of the interstitial fluid, and the value it comes around 13 mm of mercury, and the direction is outward. That means fluid moves out in the interstitial space from the capillaries. Whereas in the venous end, this reaction will be, the equation will be 12 minus 0, as the hydrostatic pressure at the venous end, capillary hydrostatic pressure is 12 mm of mercury, minus the oncotic pressure is the same, 25 mm of mercury minus 3. So the resultant pressure comes 13 mm of mercury and the direction is inward. The fluid moves into the veins from interstitial space. Now, if due to any cause plasma protein level is diminished, that means what? The oncotic pressure of the venous end, it will be reduced. So what will be the reaction in that case? We will see that at the arterial end, now the pressure will be 35 minus 0 minus 20 mm of mercury minus 3. As the arterial end, the oncotic pressure of the capillary, it falls from 25 to 20 mm of mercury. So the net outward pressure, it becomes 18 mm of mercury at the arterial end. At the venous end, it becomes 5 mm of mercury and the direction is inward. So we can say that the net filtration force, it is much lesser at the venous end. That means more fluid will leave the capillary at the arterial end, while less fluid will be absorbed at the venous end. So this fluid will accumulate in the interstitial space and it will give rise to edema. So by this way we can explain why the low plasma protein can cause edema. Thank you and subscribe.